So Laura, what species are you processing?
So this is a bat from the genus Equatorial, and now we're going to measure the forearm to know which species is exactly.
How many species within this genus have you captured here in Equatorial Guinea?
We have caught 3. So this is a forearm above 50 millimeters, therefore this is Equatorial ruber. We can also check the genus of the bat. In this case we have a female because we cannot see the penis or the testicles. Another thing that we can also check is the age of the bat. To do so, we need to check the joints of the wing of the fingers to see if they are fully fused or not.
And what is the difference in the fusion of the joints between adults and juveniles?
Okay, so if you see a shape, this is the joint, you kind of see kind of a gap here between the joint. It means that it's a juvenile because it's not completely fused. However, if you don't see any darker space or any empty space, it means that it's an adult. In this case, it doesn't have a space, therefore it's an adult.
And you guys are also collecting DNA samples. How do you go about collecting DNA samples of bats?
So for that we are going to do what is called a wing punch. We use this cutting, this surface, and we open the wing of the bat, and we extract a small portion of the wing membrane with this wing puncture. We always sterilize the tweezers and the wing puncher, so this way we are not mixing samples. And that's not a problem for the bat, these tiny holes that we make in each wing, because it has been seen by some studies that after a week the wounds in the wing start healing already. So that's not that doesn't have any problem for the bat, or it doesn't reduce its capacity to fly. And just in case, we always take both wings, a wing punch sample.
All right. And what else are you going to do to the bat to finish processing?
Okay, so we are also going to take a photo of the wing, and we need to also measure the tail. Diogo, if you want to help me with that.
Yeah, sure.
We always try to stretch it at maximum so we can have a more precise measurement of the tail.
So Diogo, the shape of the tail, does that tell you anything about the species ecology?
Yes, it does. In this case, we know that this bat is not a gleaner. So they have these bats that have a huge uropatagium. It's what we call to the tail membrane, because they capture insects from the branches. So they are flying, and they use the tail to capture the insect from the branch. These ones don't have a very huge uropatagium, as you can see, compared to other ones that in some species can go as far as here. They have really huge uropatagium. These ones, they capture insects while they are flying. And so they use echolocation. And one thing that's very interesting about this family and this genus is that they use a constant frequency during the time. Most of the species will vary their frequency with the time, and then they receive the echo, and they can see what is around them and where is the insects. This one, no, they use a constant frequency along the time, and which works exactly as a radar. So you are going on a highway, and you see the radar that is measuring the velocity of the car, and that radar is emitting a sound, and the echo is going to bounce on your car, and because you are going fast and in the direction of the car, the velocity of the echo is going to increase, and the frequency also increases. In this way, the radar can calculate more or less the velocity of the car. These guys do exactly the same, which is called the Doppler shift. They measure the Doppler shift, the distance between the surface and their movement, and if you are moving in the direction of the object, they are going to receive the echo faster. If they are moving away, they're going to receive the echo later. And this way they can navigate and capture insects around the environment, the habitat, and survive, which is super awesome.
Yeah.
And in the end, we are going to use this detector and record the echolocation of these bats. And as Laura told us in the beginning, using the forearm, we can distinguish between this species and the other species. And by using this, recording the echolocation, we can also distinguish between species, because this one emits in one frequency, while the other species emits in a lower frequency, which is super amazing. And then in the end, we can use also this recording that we are doing to analyze the data that we collect from automatic stations and identify the species that are flying in the forest besides the ones that we captured.
Excellent. All right. Thanks, guys.
Yes, please. Release the bat.
Was that successful, Laura?
Yes, we just recorded the echolocation of a bat called Ipociveros gruber. And here we can see some of the calls that the bat was emitting. These are quite faint because he was already far. But probably there are ones that are closer because this should be a nice recording because the bat was flying over our heads for a couple of times.
And what do you do with this data?
So we have also automatic stations recording the bat activity within the forest, and this way we can identify the species that we record with this automatic station, because we know the exact species that is emitting in that exact frequency and with this specific type of call.
Will other bat biologists be able to use this information as well?
Sure. One of the main interesting things to do with acoustics is to do a bat call library. So this way you can just share this information with other people, and everybody that is able to have a station recording can use this data to compare the results.
Great.